Hi, my name is Tim. I'm Senior Application Specialist at ATR Soft. In today's webinar, we will have a look at how to define file conversions. If you have any questions during the webinar, please use the chat box and then Francois will answer them as we go, or we will look into them after the presentation. There will be a Q&A session at the end to let you follow the presentation better. I expect the webinar to take somewhere in the range of 20 minutes, and the webinar is being recorded as always and will be made available online. Okay, let's get started. We have quite a few formats that we support during file conversion, and I created this list so you have a clear view of what we can do. There are some items where we add functionality over SolidWorks and some where we just duplicate what you have in SolidWorks. But if we're just going to talk about this matrix, you can see the file types that we support for file conversion, as well as the extension that these files are having. Then there is part assembly and drawing checkmarks, and these are to emphasize where you can use these conversions. So for instance, if you look at the DXF file, this can be run at part level and at drawing level. That doesn't mean that we cannot run them from assembly, because we actually can, and then it's just going to try and convert the part files from the assembly. But that is, we go into that a bit later. We also have what we call additional options, and you have those as well in SolidWorks, and I will show you. Some we just duplicate, so you have one-to-one. You can do exactly what you can in SolidWorks. But quite a few, we add a lot of functionality on top of what you can do with native SolidWorks. But basically, there is no time to waste. I want to get on with the real-time demo, so here we go. This is a assembly file with some part files in it. Actually, it's only one part file with different configurations. And if I want to start out by talking a little bit about file conversions. We have file conversions in our options. So this is the place where you need to define your file conversion. And then you just add new file conversions. If I look at one of these, for instance, the Parasolid, I can select the file type and then Parasolid and the conversion options. This is what I mean when we have additional options. These are the conversion options that we have for Parasolid. If I look at the same in SolidWorks, so here we have output as, version, flatten, assembly hierarchy, and so on. If I close everything and go back to SolidWorks settings in the export and select Parasolid here, you can see that we have the same options that we had in custom tools. And basically you can go through all of these and you can see different options, for instance, for images or whatnot. And we can do basically the same in custom tools as you can in SolidWorks. Some we do add a bunch of extra functionality onto. And this is what I'm going to show you right now. So imagine that we have this assembly that we are going to create DXF files from. Now in SolidWorks, you can do that by opening up a part file and then start clicking on a face and then export face by face. The requirement that I have for this one is that I want to create one body or one DXF file per body in a nesting folder, you could say. So whenever the guy running the laser cutter is prepared to start working, he can then just open up the DXF folder and then import all of these bodies or DXF files and start nesting and cutting. Doing so manually is quite a lengthy process. You will have to open up each part file and then go export to DXF per body. We don't want to do that. For that, we can run print and convert. And do not worry, I am going to get into the settings portion of this after you see this a few times. I already created like a batch conversion rule for this task. I'm going to create DXF files per body. Now I have a requirement that I want to have how many items I have. So if I have a body in my multi-body file, Maybe I have one of these boxes. You have 2 sides and 2 ends. I want to have instance number 1 of 2 and 2 of 2 appended to the file name. So it's easy for me to investigate what is going on. All of that you can do with custom tools. So I'm just going to process this one and let it run. During this process, we are going to batch create some drawings for you. And if you have started out using batch processing, you might have seen some errors that something went wrong. We do have some errors that are not meaningful at all, and I will show you because actually I will end up having some errors in this one. Sometimes you basically need to have your sheet format or your drawing template defined as a default template in SolidWorks. So we will get into all of that nitty-gritty stuff after this, and I will try and help you and make this file conversion thing much more easy on you. But as you can see, we are running through all of these bodies and we are creating individual DXF files, and we are pretty close to being done. These temporary drawings that we are creating, we can actually save those if we need those for any good reason. We could save those out as true SolidWorks drawing files as well. Okay, so here we are. The process has completed, but we do get some errors in our export dialog. And basically, this is for me to figure out why. I'm running an internal build. We need to figure out why we're seeing these. But if you have errors and you're sure there are no errors, you can actually suppress all of these error messages. And I will show you where you can do that. But now I've created all of these DXF files, so I'm going to close this window. Then I'm going to go into my Explore and see where the files were created. Now, the file rule that I have for DXF files is that I want to jump one level up and create a folder structure. So in this one, I have now a file or a folder called DXF, and in that I have individual, and that is just created right now, as you can see. In this folder, I have all the bodies, 1 DXF per body, and I can see that I have instance number 2 of 4, 3 of 4, 4 of 4. So if I look at the little guy, that one, I have some small items and I have 10 items selected. So if I count 1, 2, 3, 4, 5 times 2, that's 10. So I would assume that I have all the DXF file I need for this one. I also have the material as well as the material thickness in this one. So really a lot of information added to the file name automatically. Okay, let's go into the options and try and decipher this a little bit. The first one is that you can suppress or hide error messages. So in the user options, we have messages and errors, and we can actually hide errors and warnings during automatic file conversion. For some reason, it's not working in this version that I'm using right now. And I'm sorry about that. We need to figure out what is wrong. But this should suppress error messages if they are not meaningful. In my profile options is where I control my file conversion. And I'm going to talk a little bit about this DXF multi-body single that I just ran, so you can see how it's created. So these are settings for the DXF that I just ran. I can give it any name that I want. It's arbitrary. You can use any naming convention that you see fit for your profile. The file type is obviously important because what you order here is what you get. Now, this one is going to run against parts only. It could run against drawings as well. If you cannot run it against assemblies, it's simply grayed out. So you cannot make any big mistakes in here. To define the output file name, you can use our help us out here. We have browse for folder. You can use model properties, any property you have in your file, drawing properties. You can even use development properties, cut list item name, body number, and so on. Typically what we're using is the source path as well as the source file name in some kind of configuration. So in this case, I have the drawing path. Then I use a good old command trick to jump one folder up. Then I create a DXF folder as well as the individual folder. Then I start creating the file name itself. It's the drawing file name. Whatever the file is called, it's going to get again. Underscore is just static text. And then I add the configuration name. And if I go back a little bit here. Okay. So we have the config name. Then we have a body number. We have the material as well as the thickness. And I add static text again to emphasize that this is millimeters. I have the instance number of quantity. So really a lot of information goes into the file name, and I don't have to do anything to worry about this to be correct. If it's set, it's going to be correct if the properties exist on the files. Now we do have this conversion option. For DXF files, we actually add quite a lot of good stuff. One thing is that we can generate a file name from the assembly or generate a file from the assembly based on the material and thickness of your part. And we can run that on this assembly afterwards, so you can see how that is going to work out. But basically what that is going to do, it's going to look for all the similar materials and thicknesses and put those into individual DXF files. So you may have one DXF file with 20 part files, and then you have a different material and thickness. You get all the others in that one that belong to that material and thickness. There is also an option to show only silhouette edges, and what this is going to do, if you are running laser cutters or plasma cutters or any other type of cutting, you might know that if you have a countersink or counter bore on your face of your sheet metal part, that circle is going to be not good. You don't want that in your DXF file. Basically, we just strip that away. We only show the silhouette edges. If you hold a flashlight behind your part in flattened state, that is what you get. You do not see all those additional edges that will just cause problems for you downstream. We can add bend lines as well as bend nodes. If you use bend nodes, you can use, let me just activate it so you can see. We can use what we have for a general and normal bend node inside SolidWorks, but you can also add static text to a bend node in here. Here you have the option to save the temporary drawing that we are going to create during the process if you want that. I don't know if you want, but you have the option at least. And then we have an option to display a node template to every view, and I will get back into that for the next one. We also have the option to export all splines as splines, as they are basically, or we can try to convert the splines into arcs and circles instead. So some laser cutters would like to have polylines instead of splines, depending on the age, I guess, of your equipment. So cancel that one and that one. So this is the same. Now I want to run a merged DXF. I do not want to have one DXF per body. Now I just want to have all material and thickness into the same file. In that case, I have defined my target file name to be drawing path one level up, create DXF merged, drawing file name, source, config, material, and so on, thickness, obviously. And in the conversion options, I have set to display a node template to every view, and I'm using the one called laser cut info. If I look at my node templates, I have quite a lot in here, I can see. I have laser cut info. If I edit that one, you will be able to see that this is built quite the same as when you create a file name. So you can insert different properties and static text and then create nodes to be inserted in your DXF files. That is a lot of information. Let's see that in action. So I'm going to run the print and convert one more time, and this time I'm going to run the DXF part merged. Again, it's going to select the part files only because we can only process parts or drawings, and I only selected part files, right? Okay. let that run, and you will be able to see on the screen what is going on. We start up by making some, you would probably call it clutter. You don't know what is going on. You don't have to. When we have completed all of these part files, we are then going to create the layout for it. And that is being done on a drawing where we just place the view side by side and add the nodes. And you'll actually be able to see the nodes and everything being created in a few seconds. And while this is processing, the next that I want to do is create a step file conversion where I use a custom naming mask, because that is really a cool thing as well. And I will have to take you through our properties as well. So now you can see the layout with the nodes made. Okay, let's go back to the Explore folder. DXF merged. 1016, this is just now, so I've created this one single part file. Obviously, it's the same material and thickness across everything in this assembly. Had there been more thicknesses or different materials, then I would have corresponding DXF files. Let's open up this one and have a look. Okay. So now we added the node, and I can see that the material is AISI 304, thickness is 2.5 millimeters, and I need 4 of these guys. For this one, I also need 4. For that one, I need 2, and we can add the cutting length as well, so we know exactly how far the laser is going to travel around this one. So by now, you probably already realized that for quoting purposes, this is a brilliant tool. You just send one DXF file and they can do the math. They have 4 and they know the cutting length. Pretty straightforward, and definitely not something you can do with SolidWorks. Okay, let me close that one and open this guy. So I have this design. My internal file names are called the stock 0172 and so on. And I need to send that to some place for manufacturing maybe. And I don't want to give away these internal file names. I want to use the part serial number. For instance, if I have a spare parts serial number, then I want to use that instead. And to do that, I can actually write a bunch of property values. So now the design is done, and I will show you because it makes more sense. I have a sequence called serial. This is you could call it your ERP serial number for spare parts. So I have a serial number, and in my model properties, I have some PLM data. I'm going to return the year, that is the date field, get current date, and then I'm just going to return 2018. So you can do that. Again, we have this flyout where you can define exactly how the format is going to be. And then I have an item, and this is going to return the code. The get code is going to return the sequence. And then finally, I'm going to combine these two properties, the year and the item, into a combination called serial number. So now we are really getting a little complicated here. So model combination serial number is getting year and item. And I want to show you that because there are so many useful elements in custom tools, and they are kind of cross-interfering with each other. You can take benefit from everything, and you will gain a lot of productivity based on that. And you can really automate a lot of your things that you're doing. So everything is set like I want it in here. Problem is that these files do not have any PLM serial number right now. So I need to write that to the files. And I can do that by using copy, where we have the different options: save, save as, rename, move, and write property values. Write property values is a really nice tool just to batch populate a bunch of data into your files. So in this case, I will return the item code, the serial, and we get now a serial number combination defined in our design. I can hit OK, and it will then run through the files really quick. And now all of these properties are set. But how can I know? I mean, how can I know for sure that these properties are set? Well, to do that, I want to go back to my options because I want to show you another trick. You can go to your export profile and create an export profile. And basically, I just want to know if this one has a serial number. So I'm going to select the custom tools attribute, and I think it's the serial number. And these can be moved up and down by drag and drop. Okay. Running the export, and I can see that everything now has a serial number. And this is the exact number that I want to use instead of these names, right? So I don't want to have it called stock anything. I want to use that number in this list. Right. In my options, I want to create a file conversion. So this is from scratch. Now I'm creating a step conversion. Call it step. The file type obviously is a step file. I want to run this only against assemblies because I don't want to create step files of my part files. I just want to have a flat hierarchy assembly, or like an assembly with everything in it. For the file name, I would like to use the source path. And maybe I want to use a model property actually. I want to use the serial number because then I'm completely hiding the stock 0 whatever. So now I'm using a serial number. For my conversion options, and this is where we add something that you cannot do at all in SOLIDWORKS, I want to use a custom component name. So my custom component name can be anything. You can type like arbitrary text, static text, but you obviously need to have something to distinguish files from each other. If you call everything random, then you're going to overwrite the same file over and over again, which is not good. So we can add model properties or model combinations. Either one you can use. So I'm just going to use the serial number combination. That's fine for me. And hit OK. And run this conversion. So now I have defined a new export, or not an export, a conversion profile. And I'm going to select that. And this is going to select only the assembly files. And then it's going to embed all of these part files as imported bodies. So running that one. And it's actually rather quick to run these conversion rules. I mean, compared to opening each document and doing a save as, I mean, you see the benefit, obviously. Now, let's explore into that folder again. So now I have some different step files. These are created right now. I assume this one to be the one that I want to look at. So opening up that one. Yeah, let's use that template. That's fine. So now you can see that I do not have the name called stock anymore. Now it's called my spare parts serial number. Just one of the nice tools that we add for you. And by the way, coming back to what I wanted to show you as well in the SOLIDWORKS system options, if you do get errors when you try to create PDF or DXF files, then most likely a good place to start looking is your default template. Make sure that your drawing template has been selected. And it might be that it's in here, but anyway, if you find an error, just try resetting that, making sure that everything is reset basically, so that it's going to select the right template. That is one of the most typical and common errors why these conversions are going to fail. Okay. That is actually all that I had to show for you today. The next webinar is going to be Understanding Custom Tools Administration Tool. That is scheduled for Tuesday, the 15th of February, same time as today. Here we are going to explain all you need to know about users and groups and permissions and so on. It'll be a bit later on the month than you are used to, actually 1 week later, because we are attending SOLIDWORKS World in Los Angeles. If you are there, then please make sure to stop by and talk with us. I am open for questions when the recording is stopped, but first I want to thank you all for attending this webinar, and I hope to see all of you for the next one. Thank you and have a nice day.
We are in the life-saving business. We kill your routines before they kill you.